Hi, Advanced Geometry class. This is the second video for section 5.3. Not really any new notes. Well, there is a little bit of new notes. I shouldn't say that. But it's an application. So, in the design of a building, there needs to be as large of a diameter pipe as possible for drainage of roof runoff. Where the pipe needs to be run is through a triangular space in the structure of the building. How can you calculate the largest diameter pipe to fit through this space? So, just a visualization here of what's going on. You got this triangular space, but you want to run a giant pipe through that space. So you need to have as big a pipe as possible, but you only got a limited space. So this circle represents the pipe, the triangle is the space. We need that circle to fit into that triangular space as best as possible and to get it as large as possible. So we're looking to do something like this, where that circle is fitting in the triangle. It may be touching each of the three sides, but it fits in there. Okay, that's the idea. We want the biggest possible thing. So, to do that, we are, and actually before I go to this other one, what we have here, a circle, it has a center, all right? Each of these sides of the triangle, they're just touching the circle at this one point. Okay, this side down here touches the circle at that point. This one here touches right there. Okay, that is called a tangent line. When you have a line that just touches a circle at a single point, it is a tangent line. So one property, and we will talk about this later in the year, but it's kind of important for what we're doing now. When you have a line touches a circle at one point, if you draw the radius from that circle to that point, it's perpendicular. Perpendicular there. Perpendicular there. Okay, that's an important idea. So, what kind of segments that we have talked about in this chapter are, when you have a point on those segments, are perpendicular from the sides? That's right, everybody. It's the angle bisectors. Good work. All right. So, in this picture, just have a basic triangle. So, what I have drawn in, there's the angle bisector for angle B, angle bisector for angle C, angle bisector for angle A. You notice how all three of these angle bisectors intersect at a single point. No matter where I move the triangle, those things are always intersecting at a point, and we'll call it point D for now. Okay, this point, it does have a name. Well, I'm going to hold off on that. So, no matter where we move this triangle, those 3 points, remember this is called the point of concurrency. We had the circumcenter for the perpendicular bisectors. Okay, now we're talking about angle bisectors, but they all meet at a same point. So, a point on an angle bisector is the same distance away from each of the sides. You measure distance going perpendicular. So, I'm going to put in this perpendicular line from D going to side BC, which gives us point A. And now, I don't really want that line. What I want is just the segment. So, we are going from D perpendicular to side BC, giving us this. Okay. I could do the same thing for the other sides, going from D perpendicular to AB, perpendicular to AC also. But I'm not. This is really all we need. So what I'm going to do now is draw a circle centered at point D up to point E. And there's that circle. Okay, notice how the circle is touching all three sides. Wherever I move this triangle, whatever kind of shape it is, that circle is touching each of the three sides. It's not crossing the sides, it's touching at one point. Okay? So, this is called inscribing a circle. We are drawing a circle inside of a shape. So, this point D, where those three angle bisectors meet, like I told you, there is a name to it. It is called an in-center. The in-center, as it says, is the center of the circle that touches each side of a triangle. So you are inscribing a circle. drawing a circle inside of a shape. And to do that, you're using those angle bisectors. They all meet at that one point called the incenter. So back to the idea of that question. How could you figure out how big of an angle? Well, how big of a pipe could you have to fit into that triangular space? You use your angle bisectors. You draw in your angle bisectors, and you really only need two of them. If we get rid of one of those angle bisectors, we got the angle bisector from B to C, and C, they're intersecting at that point D. And you measure perpendicular to one of the sides. There's your radius for the pipe, which you can then figure out the diameter of the pipe. All right, so that's it. I like this application. There are a couple of other applications of this idea of an angle bisector. We'll try to talk about them on Monday. Please remind me to talk about them on Monday, and we'll go from there. Hope everybody has a good weekend.